Well, hi everyone and welcome to the Bush Block Homestead. Today we'll have a look through our off-grid power system for the shipping container house. So at the moment we're on the roof and we have two sets of panels here. Ignore these lower ones here, they're to do with our hot water system, and we'll go through them at a later date. So these back set of panels here were our first panels we put up. That is a set of, I believe they're 190 watts each, they're 24 volts, and that's a 2 kilowatt system or just over. We then added a second set of panels. We added another 3 kilowatts on the front to have a total of just over 5 kilowatts of solar input on the roof. In each set of panels we have 12 panels each. So we've got 12 panels in this 2 kilowatts and another 12 panels in that 3 kilowatts. These are 190 watt panels, they're 250 watt panels. The panels are wired in sets of 3. So these 3 here, they are wired together in series to give us around 110 volts max. So each set of 3 panels are all wired together. So we have this set of 3, this set of 3 here are then wired together, and so on. The same with the 3 kilowatt set of panels there. That's just because our max input voltage into our inverter is around 110 volts. So wiring each set of panels in 3 gives us just under 110 volts for our inverter. All the panels are wired in a set of 3, and then all these wires go down into the combination box down on the side of the house, which we'll look at soon, where the panels are combined. Well, here we are at the combiner box. This is where all the solar panels, the series string of solar panels, come down to combine. This group of breakers here, this is the first 2 kilowatts, and here is the 3 kilowatts. So we've got the negative terminals here, they're all combined, and the negative terminals there for the 3 kilowatts. So you can see for the 2 kilowatts, that's a set of 3 panels. These are the positive wires. So set of 3, 3, 6, 9, 12 makes up the 12 panels. And they go through an individual breaker each, and then they're combined here at this bus bar. And the same with the 3 kilowatt set of panels. This makes it convenient for testing. So we can get a multimeter, put our negative probe on here, positive probe on here, and we can check out the voltage of the first 3 set of panels, then the next and the next. And it's also good for maintenance. If we have one panel that needs replacing, we can shut down that bank with the faulty panel and still use the rest of the bank of panels, and we'll still have a solar input coming in. These bus bars over this side were just spares that I put in at the time, and they're not really needed as we have ample solar coming in at the moment. Well, here we are in the power shed, and we'll start at the input where the solar panels come in. So we've got a couple of breaker boxes here on the wall. So this is where the 2 sets of solar panels come in. You can see we've got the set of 2 kilowatt panels and the 3 kilowatt panels. So there's a DC breaker on each. That's after all the panels have been combined. So from the breaker box we've got the set of 2 kilowatts and the 3 kilowatts, which travel down this conduit and go to this all-in-one inverter. This is a giant power inverter, which is a rebadged MPP solar inverter made in Thailand. So we've had this up and running now for almost 5 years with no issues. It's a 4 kilowatt inverter, 48 volt input from your battery bank. It has a built-in DC charger, so you can charge it from mains or generator, and it also has 2 solar DC regulators. That's why we've got 2 sets of DC power cables coming in here. One is from the 2 kilowatt bank of solar panels, and the other one is the 3 kilowatt bank of solar panels. So you can see our current solar input is around 1.8 kilowatts with a 240 volt output. Here we have our 48 volt battery bank. These are 12 volt AGM batteries. So they're wired in sets of 4 in series to make 48 volts, and we have 2 banks of 48 volts, and then that's wired in parallel to double the capacity. From these batteries they go across into a main breaker, which is a main fuse breaker. We have a main battery disconnect switch, and the negative side goes into a bus bar which measures our input and output power coming in and out. That bus bar is connected up here to this Victron energy meter. You can see our battery percentage is 91.5%. We're probably taking a bit of power out now. So we've got 1.3 kilowatts coming in. You can see we're down 57.7 amp hours out of the battery bank. That's our total percentage in the battery bank at the moment. I have an alarm set at 70%, so we never withdraw more than 30% of the available power out of the battery bank. You should never draw more than 50% out of a lead acid battery bank, so you can have maximum life, and we actually don't draw any more than 30%. Up on the wall here you can see these are battery balancers. I've upgraded. I had some homemade balancers that I put up. I've replaced them with these Victron energy battery balancers. Above them you can see the voltage of each separate battery. So those two, you can see these meters here actually correspond to each battery. Those battery balancers top balance these batteries, so each 12 volt battery will be in balance with each other. The meter second from the right there, that actually reads slightly lower than it should. It's out of calibration, so I need to calibrate that or replace it if I can't calibrate it. So the battery balancers are doing their job at the moment. We have a temperature gauge in the power shed just to monitor the temperature in here. Also connected to the battery bank is this battery extra, which gives us our total voltage. So you can see we have 57.8 volts. This is also a battery pulsar, which is supposed to pulse the batteries to remove sulfate and give them extra life. So after the battery disconnect and the negative side here, it comes across and goes into this other fuse box, which then leads into the DC input of the inverter. On the AC side of the inverter, we've got the AC power coming out. We've got the AC power coming out, which goes through this conduit along the wall here, and then we've got a couple of AC breakers that go to the power panel on the house. So we've got an AC out. We also have a generator input. So we go back to the inverter. This power here, that's the generator input. So if our batteries are low in cloudy weather or a few days of cloudy weather, something like that, we have our DC brake for the generator, which is turned off at the moment. We have a power point down here. We can just plug a generator into here. We have a 2 kilowatt inverter generator which we can plug into there and just start that up. Switch this breaker on, and then the house will run off the generator and charge the batteries at the same time through the inverter. So the batteries we are currently using are these Predator batteries. They're 220 amp hours each. So we have 2 sets in parallel, so that gives us a total of 440 amp hours each, and at 48 volts that gives us 21,120 watt hours, or 21 kilowatt hours of storage at 100% capacity. But you should never use that much out of a lead acid. So at 50% capacity, that would give you 10.56 kilowatt hours of storage, and we only ever use a maximum of 30% out of the batteries. So at that we would have 6.336 kilowatt hours of storage, or 6,336 watt hours of storage in our battery bank if we only draw out 30%. We were running these batteries over here, which AGM, they're Giant Power. They're a Chinese made battery. Do not recommend them at all. We had a few under warranty. We had a few claimed under warranty after 12 months, and then all the rest started to fail after that. So I do not recommend giant power batteries. So hopefully these ones here will last us a while. They're only installed, we write the date on them, September 2020. We've had no issues so far. Also on the power shed we have this automatic ventilation system, which is pretty simple. It's just two PC fans out of a computer, and they are directly connected to a 12 volt 20 watt solar panel. So when the sun comes up in the morning, the fans turn on, and when it goes down in the afternoon, obviously the fans turn off because they're no longer powered by the solar panel. No controls necessary, just wire the fans directly to the solar panel. Makes for a simple ventilation system.